Okay, so we're going to start reviewing for your first test of the second quarter. That's going to be on Tuesday, November 20th. Okay, so your corrections are due on the 20th. So for the first question, it wants to know, find the inverse given the following function. So if you remember, an inverse function is when you switch x and y and you solve for y. So now this is x equals y minus 5 squared divided by 4. So now I have to solve for y. So I'm going to multiply both sides by 4 to get rid of that 4 there. So now I have 4x equals y minus 5 squared. To get closer to the y, I'm going to take the square root of both sides. So now I have the square root of 4x equals y minus 5. I don't have to worry about the plus or minus for this because it wants the function. So now I have y equals 5 plus the square root of 4x. And then finally my answer I need to write in the correct notation. So this is my answer for number 1. 5 plus the square root of 4x. For number 2, simplify the following expression. So this deals with my exponent. So everything inside my parentheses is being raised to the negative second power. So I'm going to actually go through and do that. So now this is 5 times x to the negative 6. Remember, power to power you multiply. Y to the 0 times negative 2 is 0. And z to the negative 4th times negative 2 gives me z to the positive 8th. Divided by, nothing happened in the bottom. This all stays the same. Now I'm going to go through and worry about my negative exponents. Here, actually, you know what? Before I do that, y to the 0, anything to the 0 power is just 1. So this can get crossed out, right? Anything times 1 is just itself. And then here I have to move these exponents around. Okay, negative 6, that becomes a positive 6 when you move it to the denominator. And then x to the negative 8th becomes x to the positive 8th when you move it to the numerator. So now I have 5x to the positive 8th, z to the positive 8th, divided by x to the positive 6th, y to the 5th, and z to the 3rd. So then lastly, 5 divided by 1 is just 5. X to the 8th divided by x to the 6th is x squared in the top. My y's, there's nothing to divide or combine, so it's just y to the 5th in the bottom. And then x to the 8th divided by, z to the 8th divided by z to the 3rd gives me z to the 5th in the top. And that's my answer. For question number 3, find the vertex form of the parabola. So vertex form, that's when you have to use completing the square. So first I'm going to add 12 to both sides. Don't forget this is negative x squared plus 16x. In order to do completing the square now, my a value has to be 1. Right now it's negative 1, so I'm going to divide everything by negative 1. Y divided by negative 1 just becomes negative y minus 12 equals x squared minus 16x. And now I can go and do completing the square. So I take negative 16 and I divide it by 2. Right, I cut it in half. And now I'm going to square it. Negative 8 squared is a positive 64. So now this is negative y plus 52. And then lastly, I have to factor out any number that's in front of y. Right now it's a negative 1. So I'm going to factor out a negative 1, and I'm left with negative y divided by negative 1 is y. 52 divided by negative 1 is negative 52 equals x minus 8 squared. So if the question then asks me for the vertex of this parabola would be 8, 52. Okay, but it doesn't ask for that in this question. Okay, so now we're going to talk about the key features for only this function. Okay, so I'm actually going to pause this now, so you should too. I'm going to draw a little graph on the side. That way I see what I'm working with. Okay, so this is my function in the top right up here. So the domain and the range, my domain, if you look, this is going all the way up and left, all the way up and right. Because it's going all the way left and right, again, my domain is my x values. My domain here is all real numbers. Or if you wanted to say from negative infinity to infinity. You could say that too. My range, though, you can see the smallest y value is whatever this point is down here. So I have to figure out what that point is, but then it goes all the way up to infinity. So once I get this minimum value, I can actually finish my range. So I'm going to kind of do that and number 5 at the same time. So to do mins and maxes, I'm going to do second trace numbers 3 and 4. Now, if you were looking at your calculator and you saw it and you were on Zoom 6, your standard 10 by 10 window, you actually are not going to see this minimum. So you're going to have to go into your window and change your lowest y value. So you change y min. I just made my y min at negative 25. That way it goes down enough so I can see it. And then I did second trace number 3 to figure out what this minimum point is right down here. So this minimum is 1.28. I'm going to round to the nearest hundredth. I know it doesn't tell you where to round to. 1.28 and then comma negative 19.83. So now I'm going to head back up to my range for a second, because my range, I needed that point to figure out what my range was. So my smallest y value is this negative 19.83 number, and that's my range. Okay, so for mins and maxes, I already found one min. I have two mins, right? One of my mins is 1.28 comma negative 19.83. So now I'm going to go back up and I'm going to figure out what the other min is, and then I'm going to find what that maximum point is. So pause your screen now and then find those 2 points. Again, you're going to do second trace number 3 and second trace number 4. For that other min, I had gotten negative 2.0000, right, which is really just negative 2, comma, my y value, I ended up getting 1.8 e negative 11. So be smart about that point. You see it's hitting the x-axis, which means that my y value is 0. If it has e in it, that means scientific notation. So it's really 1.8 times 10 raised to the negative 11th, which is really 0.00000, so on and so forth. So really this point is negative 2 comma 0. And now I'm going to find the max. And for the max, round to the nearest hundredth, again I got negative 0.78 comma 6.45. Okay, for increasing and decreasing, I'm going to make a number line of my mins and maxes, just the x values. So this is negative infinity. Oops, what's happening? This is negative infinity. This is positive infinity. And then I'm going to go in order. So my first min, my first thing is a min, and it's negative 2. Then next I have a max at negative 0.78. And then I have that other min at 1.28. So I'm going to put them in order. So negative 2, negative 0.78, and then positive 1.28. So if I look at my graph over here, from my leftmost point until that first min at negative 2, I am decreasing. And then I change direction and I start to increase. And then I decrease again, and then I'm increasing. Once you have this number line, your increasing and decreasing interval just gets pulled right from that. So I start off by decreasing. So from negative infinity until negative 2, I am decreasing. And then from negative 2 until negative 0.78, I am increasing. And then I am decreasing again from negative 0.78 until 1.28. And then I end off at increasing from 1.28 until infinity. If you have more than one interval, you're going to put the union in the middle. Just means that there's more than one. Okay? For number 7, we're going to do some algebra work. So we're going to find the x-intercepts algebraically. Okay, so this function, so x-intercepts are where your y value is 0. So I'm going to plug in 0 for y. So this is 0 equals 2x to the 4th plus 4x to the 3rd minus 8x squared minus 16x. So now that's what I'm solving for. All right, so in order for me to factor this, first I always look for a GCF. My GCF here is 2x. When I take out a 2x, I'm left with x to the third plus 2x squared minus 4x and then minus 8. So now I have 4 terms. The way that I factor 4 terms is to try and do grouping. So I split it down the middle. On the left side, I take out an x squared as my GCF, and I'm left with x plus 2. On the other side, I can pull out a negative 4, which leaves me with x plus 2. So then I have x squared minus 4 times x plus 2. But I'm not completely factored still. Right, I take the 2x and I put it out front. But I'm not completely factored still because of that x squared minus 4. If you remember, x squared minus 4 using dots becomes x plus 2 times x minus 2. Now, I'm going to be conscious that I have to do the multiplicity in 2 more steps. So I'm going to rewrite this a way that's going to help me out with my multiplicity. I know that x squared minus 4 becomes x plus 2 times x minus 2. And I already have an x plus 2. So I'm going to write this as 2x times x minus 2. And instead of writing x plus 2 and x plus 2 twice, I'm going to write this as x plus 2 squared. That way it's going to help me out a little bit with my multiplicity in a second. So 2x equals 0, that gives me x equals 0. So this point is 0, comma 0. X minus 2 equals 0, which gives me x is equal to 2. So this point is 2, comma 0. And x plus 2 squared equals 0 gives me x equals negative 2. So this point is negative 2, comma 0. Okay? You know what? Let's jump down to multiplicity now that we're just talking about that. So for multiplicity, I'm only doing that for x-intercepts. I don't care about the y-intercepts with multiplicity, right? Because every y-intercept is going to cross through the y-axis. It's not going to be tangent because then it wouldn't be a function. So for multiplicity here, multiplicity again is the exponent that it's talking about. So if I look at x equals 0, this root, that came from 2x. 2x has an exponent of 1. If I look at the root x equals 2, that came from the factor x minus 2, which has an exponent of 1. And then if I look at x equals negative 2, that came from x plus 2 squared, so that multiplicity is a 2. So if you look, you have 2 places where your multiplicity is odd, and 1 place where it's even. So if you come back up here and look at your graph, you should have 2 places where it crosses the x-axis. What you do, you have it at, well, this should be crossing through here, that way. It's a bad graph. But it crosses right here, and it crosses right here. There's 2 places where it crosses because there's 2 places where the multiplicity is odd. And then at x equals negative 2, my graph is tangent. And that's why the root x equals negative 2 has an even multiplicity. So for my statements, I'm going to combine x equals 0 and x equals 2 because they both have the same multiplicity. So this is at x equals 0 and x equals 2. The multiplicity is odd. So f of x crosses the x-axis at x equals 0 and x equals 2. And then now I have to make a statement about the even multiplicity. So at x equals negative 2, the multiplicity is even, so, or which means f of x is tangent to the x-axis at x equals -2, which makes sense according to my graph. All right, so now we'll head back up and do the y-intercepts. Y-intercepts algebraically are actually pretty straightforward because here, for y-intercepts, that is where x equals 0. So when I plug in 0 for x, I get y equals 2 times 0 to the 4th is 0, plus 4 times 0 to the 3rd is 0. -8 times 0 squared is 0. And then -16 times 0 is 0. So you just get y equals 0. So that point is 0, 0. Remember, if you do not write the points for the intercepts, you will lose. All right? And now for even, odd, or neither algebraically. Even, odd, or neither, this talks about the symmetry. Okay, this deals with the symmetry of the graph. So for this, I know f of x equals what it equals, and then I have to plug in f of -x. Okay. Okay, so I have f of x. Now I'm going to plug in -x. So this is 2 times -x to the 4th plus 4 times -x to the 3rd minus 8 times -x squared minus 16 times -x. So when I clean this up, -x to the 4th becomes positive x to the 4th, so it stays the same. -x to the 3rd is negated, so now it's -4x to the 3rd. -x squared still stays positive because of the even exponent, so now this is still -x squared. And then -16 times -x is a positive 16. So if you look here, this is a positive 2, positive 2, positive 4, and then -4. So that's a problem because they're not all the same or all opposites. So this is actually going to be neither odd nor even. But let's say you didn't know how to work with that. What you would do is cheat. You would plug in f of 3 and f of -3 into your calculator. When you plug in positive 3, you get 150, but when you plug in -3, you get 30. So you actually get two numbers that are not opposites and are not equal. So that means that it's going to be neither odd nor even. So that means that there's f of x is not equal to f of -x, and negative f of x is not equal to f of -x. Okay, so this tells me, and we'll go through everything, this tells me that it's not even. This tells me it's not odd. If it's not even, there's no line symmetry over the y-axis. If it's not odd, that tells me there's no rotational symmetry of 180 degrees around the origin. And that's it. And then lastly, the end behavior. Again, if you look at your graph, end behavior deals with the arrows. You will see that they both go up. So as x approaches -infinity, as my graph goes to the left, f of x is going up. So f of x approaches positive infinity. As x approaches infinity, as it goes to the right, f of x is still going up to positive infinity. 12 through 14 talks about transformations. Now, if you remember when we did this in class, we had that chart with all of the rules that we were figuring out. So we just have to go through and state what the rules are. And that's what this is saying. State all transformations performed on f of x. So g of x, the image function, is equal to -4 times f of x minus 3. So we have to follow PEMDAS for these. So first I have to do what's inside the parentheses. Whenever I subtract 3 directly to x, that's going to be a horizontal shift, which means I'm either going left or right. So because it's -3, I'm going to the right 3 units. Okay, And then the negative 4 is actually two separate transformations. The 4, because 4 is larger than 1, that tells me that this is a vertical stretch by a factor of 4. And then the negative out front, you're negating the entire thing. So you're negating all of y, which means this is a reflection over the x-axis. And that's all this question wants. For number 13, same thing, have to follow PEMDAS. So that negative x, you're negating x. Whenever you negate, that's when you reflect. This is a reflection over, you're negating x, so it's a reflection over the y-axis. Then you have the multiplication, so the 1/2. If you are multiplying by something that is smaller than 1, the absolute value is smaller than 1, because if it's negative, that again, that deals with the reflection. That is a compression or a shrink. So you're pushing down on the function, it gets wider. So this is a compression by a factor of 1/2. And then the +8 on the end tells me that this is a vertical shift. Because it's vertical, you're either going up or down. Because it's positive, you're going up 8. And that's it. And then lastly, for number 14, I have 4 things happening here. The first thing is what's inside the parentheses. That's a horizontal shift to the left because it's a positive. Left 2. Now we have the multiplication. So 5/4 is what I'm multiplying by. Again, the negative deals with the reflection. The 5/4 is either going to be a stretch or a compression. 5/4 is larger than 1. So if it's larger than 1, that is a stretch. So it's going to get more narrow, the function. Stretched by a factor of 5/4. Then the negative, you are negating the entire thing. You are negating all of y. So that's a reflection over the x-axis. Over the x-axis. And then the -1 on the end, that's a vertical shift. And because it's -1, you're going down 1. Okay, so these are rules that you just have to memorize. If you do forget something, you can, of course, type it into y equals in your calculator to try and figure out how it shifts. And then lastly, we have the systems, and that's kind of been like our big topic that we've been doing this week. So we have circle linear and we have quadratic linear systems. And this says that I have to justify my solution, so I have to plug in my answers at the end to check it. Okay, for number 15. This is a quadratic and a linear. So I'm going to set both equal to y. So this is really y equals, I'm going to add 15 over, 5x plus 15. So now I'm going to solve, and I'm going to plug this in for y in the other one. So this is 5x plus 15 equals 3x squared plus 14x minus 15. I'm going to subtract 5x and 15 over. That way I could try to factor to solve. To make this a little bit easier on myself, everything here is divisible by 3. So I'm going to divide everything out by 3. And now I'm going to factor. So two numbers that multiply to be -10 but add to be a +3 are going to be positive 5x minus 2x minus 10 equals 0. Factor by grouping, x times x plus 5 minus 2 times x plus 5. So this is x minus 2 times x plus 5 equals 0. So this is x minus 2 equals 0, so x equals 2. Over here, x plus 5 equals 0, so x equals -5. And then I plug these back in to get the y values. So I'm going to plug it into this linear equation up here. Y equals 5 times 2 plus 15 gives me 10 plus 15 is 25. So this point is 2 comma 25. You have to write it in parentheses. Over here, y equals 5 times negative 5 is negative 25 plus 15 gives me negative 10. So this point is negative 5 comma negative 10. Okay, I'm only going to justify numbers 15 and 16 just to save a little bit of time. It's the same thing though when you go to justify 17 and 18, just so you guys know what you're doing. So to justify, you have to plug into both points into both equations. So I'm going to do 2 comma 25 first. So my first equation is y equals 3x squared plus 14x minus 15. So y equals 3 times 2 squared plus 14 times 2 minus 15. So take a second now and plug that into your calculators. Okay, you end up getting 25 equals. Over here, when you type this in, you should have gotten 25. That's one check done. You have to do 4. So now I have to do the other one. So y minus 15 equals 5x. I'm doing the originals. So y minus 15 equals 5 times x. So here this gives me 10 equals 10. That's another good one. So 2 checks. So now I have to change points. I'm going to do negative 5, negative 10. So again, I'm going to plug in. So negative 10, or my y value, equals 3 times negative 5 squared plus 14 times negative 5 minus 15. I type that right into my calculator right here. And when I type that in, I get negative 10. Negative 10 equals negative 10. It works. Now I'm going to do the linear. So negative 10 minus 15 equals 5 times negative 5. Over here I get negative 25 equals negative 25. Good to go. Okay, and that is my second check. So if you look, I have 1, 2, 3, 4 check marks, 2 points, 2 equations to plug into. Okay, number 16. So for number 16, this is a circle linear. This circle has a center at 0, 0 and a radius of 15. And then my linear equation, this is really y equals negative 3x minus 15. So I'm going to plug that in for y into the linear. So this is now x squared plus negative 3 minus 15 squared equals 225. This is important. Negative 3 minus 15 squared, you have to rewrite out twice, please. So this is negative 3x minus 15. Negative 3x minus 15. You have to double distribute. And don't forget it equals 225, not equals 0. So then when I go to solve this, I get x squared plus 9x squared plus 45x plus 45x gives me plus 90x. And then plus 225 equals 225. Over here, when I combine like terms and subtract 225, I get 10x squared plus 90x equals 0. I factor out 10x. I am left with x plus 9 equals 0. So this is x equals 0. This is x equals negative 9. I'm going to plug it into the linear. So y equals negative 3x minus 15. Y equals negative 3x minus 15. This gives me y equals negative 15. So this point is 0, comma, negative 15. And then on this side, y equals negative 3x minus 15. 27 minus 15 gives me 12. Negative 9, comma, 12. So now I have to plug in both points into both equations to make sure that they work. So I'm actually going to erase a little bit of this old stuff from before. Okay. So it's important to remember too when you're plugging this in that you put parentheses around anything negative because it's being squared. So I'm going to do 0, 15 first. I'm sorry, 0, negative 15. So x squared plus y squared equals 225. I plug this in with parentheses. I get 225 equals 225. That's my first check. Now I have y equals negative 3 times x plus 5. I can type this into my calculator and I end up getting negative 15 equals negative 15. That's my second check. For the other point, negative 9, 12. X squared plus y squared equals 225. This is 81 plus 144, or you could type it right into your calculator. So 225 equals 225. That is my third check, and now I have to do the last one. So y equals negative 3 times x plus 5. I get 12 equals, I plug this into my calculator, and I get 12. That's my fourth and final check. You need to have your checks because this says to justify. So you're basically saying, no, I'm definitely right because this is how I know. Okay? I'm not going, just to save time on this video, I'm not going to justify 17 and 18. If you have a question about it, you can send me a message on Remind. But when you plug them in, everything should work out. If it doesn't work out, then you had done something wrong in solving for the points, in solving the system. Okay? All right, number 17, we have another quad linear. So I'm going to set both of them equal to y. So this is y equals negative 2x squared plus 4x plus 9. And this is y equals negative 2x plus 1. So when I set them equal to each other, right, I'm really substituting y in for y. I have negative 2x plus 1 equals negative 2x squared plus 4x plus 9. I'm going to bring everything to the left. That way my x squared term becomes positive. So this is now 2x squared. Negative 2x minus 4x is negative 6x. And then 1 minus 9 is negative 8 equals 0. To make it easier on myself, I'm going to divide everything by 2 so it's a little bit quicker. So now I'm going to factor it by master product. So two numbers that multiply to be negative 4 but add to be negative 3 are going to be negative 4x and 1x. Split it down the middle. Take out your GCFs. And I end up with x plus 1 times x minus 4 equals 0. So this is x equals negative 1, and this is x equals 4. So I'm going to plug both of those back into my linear to get the y values. So y equals negative 2 times negative 1 plus 1. This gives me y equals 3. So this point is negative 1, 3. For the other one, I'm going to do the same thing. Y equals negative 2 times 4 plus 1 gives me y equals negative 7. So this point is 4, negative 7. And then I would justify, so I plug in 4 times. And then lastly, number 18. So number 18, I have x minus 6 squared plus y plus 4 squared equals 36. So the center of that circle is 6, negative 4, and the radius is 6. And then my linear, I have y plus 16 equals x. So I don't have to really manipulate my linear if I don't want to because I have x equals. So I'm going to plug this in for x. So now I have y plus 16 minus 6 squared plus y plus 4 squared equals 36. So I'm going to make this y plus 16 minus 6. I'm going to be smart about this. I'm going to make this y plus 10 I'm going to combine them. I'm not going to go through and multiply more than I have to. So remember, this is really y plus 10 times y plus 10 plus y plus 4 times y plus 4 equals 36. Do not forget that equals 36. So when I go through and double distribute, this gives me y squared plus 20y plus 100. And then on this side, I get y squared plus 8y plus 16 equals 36. I'm going to combine like terms and subtract the 36 over. And that gives me 2y squared plus 28y. And then 100 plus 16 is 116. But then minus this 36 gives me a positive 80 equals 0. I'm going to make it easier on myself because everything's divisible by 2. So this is y squared plus 14y plus 40 equals 0. When I do master product and I finish, I should get y plus 10 times y plus 4 equals 0. So y is negative 10 and y is negative 4. This tells me then my x value is y plus 16. So x equals y plus 16. This is x equals 6. So this point is 6 comma negative 10. X equals y plus 16. This is x equals 12. And this point is negative 4 comma, oh, I'm sorry. Remember, x's have to come first. That's the mistake that I almost just made. X's have to come first. So this is 12 comma negative 4. 12 comma negative 4. But technically I'm not done because I'm supposed to plug these back in. Okay, so you do your checks. You have 1, 2, 3, 4 checks to do. Remember, this is x minus 6 and x plus 4. All right. If you have any questions, you can send me a message on Remind. Extra help is going to be after school on Monday. Okay, watching this video again is due by Tuesday, the day of your test. All right, have a good weekend.